Welcome to Nth Roots Part 2. Let's get started. Alright, just a quick clarification. This is the back page of your Unit 4 Nth Root notes. So we were working with radicands that were numbers, and now we're working with radicands that are variables. Remember, radicand is just what's under the root. So here are a couple examples. This is the first example that you have on your paper. A squared, or the square root of a squared, we're going to turn it into rational form, just like we did with the numbers. So this would become a 2 over 2. The top 2 comes from this right here, and the denominator comes from whatever root it is. And since it's a square root, that's a 2. And then from here you just simplify. That's 2 divided by 2 is 1. So that's a to the power of 1, or just a. Now number 13 on your paper is this one right here, a to the 4th. So again, we just turn this into rational form. We take whatever this exponent is, and that's the numerator in our rational form, and over 2 because this is a square root. Simplify. 4 divided by 2 is 2, so our answer of the square root of a to the 4th is a squared. Now I'm going to skip over to number 20, and number 20 on your sheet is the cubed root of a to the 81th power. Same thing here. Turn it into rational form. 81 over 3, and 81 divided by 3 is just 27. So our answer is a to the 27th power. So go ahead and take some time to do numbers 14 through 19 on your sheet, just the way we did in these examples. Now that we're good with variables as the radicand, let's see what happens when you have more than one of them. So here we have got square root of x squared y to the 4th. All you want to do is split that up, so we can do one at a time. So the square root of x squared times the square root of y to the 4th. So you see all we did was split them up so we can deal with them separately. And then from here we do just like we did in the previous examples. Put them into rational form. 2 divided by 2, and this one is 4 divided by 2. And then we keep simplifying. 2 divided by 2 is 1, so this one just becomes x. And 4 divided by 2 is 2, so this becomes y squared. So here's your answer. So the square root of x squared y to the 4th is x y squared. Same thing over here. Let's split up all three of these. We've got a number, so let's split that. Square root of 9, square root of x to the 4th, square root of y to the 6th. There should be a 6. See if I can fix that here. There we go. And then we do them all separately. The square root of 9, you know, or you can find it on your calculator, is 3. The square root of x to the 4th, you can put in rational form, 4 over 2. And then square root of y6 becomes y6 over 2. Then we just simplify. And now we have 3 x squared y cubed. So go ahead and do numbers 23 and 24 on your own. Now what happens when the exponent is not divisible by the index number? What this means is if we were to split this up into square root of 36, square root of x to the 6th, square root of y to the 5th, you can see here, let's go ahead and do this. Square root of 36 is 6. This becomes x 6 divided by 2. And this would become y 5 divided by 2. And that's what I mean that it's not divisible, is that 5 divided by 2 gives you a decimal. And we don't want that. So you have to split up y to the 5th. And in this case, I'm going to split it up into the square root of y to the 4th. This is a 4. Times the square root of y. So I still have 5 y's, y to the 4th and y to the power of 1. That's y to the 5th. But now I can do this, because this would become y 4 over 2. Now this over here, we wouldn't be able to do, so we would just leave it like that. That's kind of, there's a saying that only 2 can leave the party, so they have to be in pairs for them to be able to get out of this radicand, for them to leave the party. So this y, since he doesn't have a pair, or he won't be divisible by 2, so he's stuck inside this radical, so he can't leave the party. So then if you simplify all these together, we still have 6. This became x to the 3. This right here that we split up becomes y squared. And then, like I said, he can't go anywhere, he can't leave. So he just stays as the square root of y. So let's try the next example together. We've got square root of 10, which we're going to split up, times the square root of x cubed, times the square root of y, times the square root of z squared. Now, square root of 10 is as far as it goes, so we're going to leave it there. It's going to stay the square root of 10 all the way to the end of the answer. Square root of x cubed. Now remember, you can't do 3 divided by 2, so we need to split this up into square root of x squared and the square root of x. Well, can only leave the party in pairs. This guy's going to have to stay under the radical. This square root of y stays, so it can't do anything else. And the square root of z squared becomes z to the 2 over 2. So now we're kind of making a tree, if you want to call it that, where we're splitting everything up and simplifying them by themselves. So let's go back, and we've got the square root of 10 is still the square root of 10. Square root of x squared, remember that becomes x 2 over 2, so that becomes x. Square root of x, remember he can't leave, so he's stuck. Square root of y is still there. And then z 2 over 2 is just z. Alright, so this is technically your answer. This is as far as it goes. But we want to kind of put these together. So the ones that left the party, the ones that are out of the radical, or the square root, we can write them together here at the beginning, x, z. And then the ones that are still stuck in the party, you can put them together as well. So xz square root 10xy. That would be your final simplified answer. Alright, so this isn't on your notes, but I want you to see what this looks like. We have the 5th root of x to the 13th power. Now you know if you put this into rational form, just like we were doing, you've got x to the 13 over 5, which you can't simplify because it doesn't divide into a nice number. So we have to do something like we did before when we said that you had to leave the party in pairs. But in this case, you need to look at the nth root. Since it's the 5th root, your x's have to leave the parties in groups of 5. So we can split x to the 13th into x10 and x3. So here we still have 10 and 3 is 13. We still have the same number of x's, but we're splitting them up. So groups of 5 can leave the party. So here's x, and you put this in rational form, 10 divided by 5, which you can divide, and becomes x squared. Over here, he didn't have enough people to leave the party or leave the radical, because 3 divided by 5 wouldn't work. So you still keep it like this. And this would be your answer here. So make sure you pay attention to what this root is, and that's how you have to split up your radicand. Alright, that's it for now. Thanks for watching, and see you soon.